Okay, we are going to be solving equations with variables on both sides, meaning that there are x's or letters on both sides of the equation. Now, first off, we're going to have to figure out how to write our equations from the tiles. We have first right here, I've got two x's. So on your paper, you should write 2x, and I have 1, 2, 3 units plus 3. The line right here is equal, so put equal. On the right-hand side, it has a negative x and 3 negatives. So all I've done is written what they've represented in tiles, okay? I'm going to go like I've done all my other equations. I'm going to draw my line for the equals. Now on your paper, if you write really big, you may need a separate sheet of paper in order to write all your steps out. What we need to do is to make sure all our x's are on the left-hand side and our numbers are on the right. It's not that you always have to have your x's on the left, okay? It's just that you have to separate them. X's have to go to one side. Numbers have to go to another. The reason why I'm telling you to send your x's to the left is because our next, what we're coming up later on in one of our next units is called inequalities, greater than and less than. And if your x's, if your variables are on the left-hand side, it makes it a whole lot easier. Okay? So, to move these x's to the other side, I have to do the opposite. So, this says negative x. So I need to add x to each side. Now, tile-wise, see how there's a negative x right here? To move it to the other side, I have to do the opposite. So I add a positive x to each side. What I do to one side, you have to do to the other. Now, on the left side, look in the tiles. I have 1, 2, 3 x's. Well, with the algebra, I have 2x plus 1x, which is 3x. And then 3 units plus 3 equals. On the right-hand side of the equation, I have a positive x and it takes away a negative x. See, this makes 0. And then I'm left with 3 negatives. All right, so now to solve my equation, so now this is just a regular two-step equation. I need to move the 3 to the other side. So I'm going to put minus 3 to each side, and I get 3x equals negative 3 minus 3 is negative 6. Now, I don't want you to draw the tiles after that first step, just because we don't need that right now because we should know how to do the two-step equations. Then you're going to divide by 3. X equals negative 2. Now, we have to check it, and we check it just like we've done it before. Left-hand side goes into y1. So over here where it says y1, I want you to put 2x plus 3, and the right-hand side into y2, negative x minus 3. Now, when you go in the calculator, and when you're writing this in the table, so let's see here, I'm going to go to y equals 2x plus 3, and in y2, I have negative x minus 3. Oh, let's see. I got to erase the rest of this. There we go. Second graph. I believe the answer is negative 2. Now, I'm just going to scroll to where it says negative 2. And you know you're right if y1 and y2 are the same. So in your table, here is what I need you to see for this. Need you to write down for this assignment. I'm going to write negative 2, negative 1. I don't really care which other numbers are in here except that I want to see the solution written in there. I have to see that, and I'll show you why in a minute. Let's see. Negative 1, 1, 3, 5, and 7. It's easier for some of y'all because the calculator, you can keep it up. Mine, not so much. Now, after you fill in the table, what I want to see you do is circle where the solution is. Because sometimes on your tests, they're just going to give you your table, and you're going to have to be able to tell me what the solution is based on your table. Let's look at number 2. Number 2 again has the tiles, so algebraically, let's represent it. This is a negative x, and then I have plus 4 equals, because that's what that line means right there, negative 2x plus 6. Please right now make sure on your paper you are on the correct side. Make sure that we have the right problems and that your problems are matching mine. Okay? Last period, people were doing the wrong side. It should be the guided practice. All right. So the equal to bar, I know now some of you are like, oh, okay. All right. I need to move these two x's over to the other side because I want to move my x's to the left. Since they're negative, we're going to draw two positives. And what you do to one side, you have to do to the other. So algebraically what I did was I saw this negative 2 and negative 2x. I got to move it over there, so I've got to do plus 2x to both sides. Now a positive takes away a negative on the x's, and what I'm left with, 2 minus 1x is 1x plus 4 equals. These x's cross out, and I'm left with 6. Now, like our regular one-step equations, subtract 4 from each side. X equals 2. That's what I believe the answer is. So to put it in the calculator, I'm going to put the left-hand side into y1. So I'm going to put negative x plus 4 and y2 negative 2x plus 6. I expect you to have all of this filled out. Everything that I'm writing on this guided practice, when you turn this in, you need to have that on your paper as well. So I'm going to go to y equals. Make sure you clear them out. And I've got negative x plus 4, negative 2x plus 6. Second graph. I believe the answer is 2. And look, it says 2, 2, and 2. Okay, well, that's good. That means I've got a right answer. So I'm going to write in here 0, 1, 2, 3, 4. And I said it was 2, 2, 2. Okay, let's see. What were the other numbers? I started at 0, so it's 4. 6, 4. Okay. Again, I want to see you circle where the solution is. I need to see that on your paper. The solution is where y1 and y2 are the same. It just happens in this one that the x number is 2 as well. That's a coinkydink. All right, so the next one. This time they don't have the tiles. They give us the equation, so we need to draw the tiles. And it says 8x. So right now, let's draw 8 x's. Everybody should be drawing these. Miss Gray, you already drew them. Good job. All right, 2x. Now, if you can tell already, the reason why eventually we want to get away from tiles is because I don't want to sit here and have to draw 18 negative tiles all the time. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, my goodness, 13, 14, 15, 16, 17, 18. Okie dokie. All right. Draw a line at my equal sign. I need to look on the right. We're like Beyonce. To the left, to the left. Oh, no, yes, I killed it and went there. All right, so I'm moving my x's to the left. All right, so to move them over there, I have to do the opposite. So I have to put 2 negative x's. And what I do to one side, you must do to the other. So looking up here, remember I need to move these x's to the left. You don't get to just put them there. You have to do the opposite, minus 2x. When you cross out your 0 pairs on the left-hand side, 8 minus 2 is 6x. On the right-hand side, 2 minus 2 is 0. That's why we did it. And it equals negative 18. Now, divide by 6. I get x equal negative 3. See, when you did this before, like with equations, you guys used to have to split them up, like you'd have all your tiles and you split up your little units, but we're not doing all that, just the first step. So now we're going to put the left-hand side into y1, right-hand side into y2. So I have 8x, 2x minus, whoopsie daisy, minus 18. So let's get the calculator. Y equals, everybody should be doing this. You have to be able to press the buttons. You can't just watch me do it the whole time. 8x, and I have 2x minus 18. Second graph, I believe I can fly. No, just kidding. I believe the answer is negative 3. Y'all are no fun today. Y'all need to wake up. Okay. Y1 and Y2 are the same. They're both negative 24. So, negative 3, negative 24. Let's see. Negative 6, negative 8. Whoa, that wasn't it. Negative 16. Okay, remember, once you fill it in, circle where your solution is. Remember, it's a solution because y1 and y2 are the same number. That means that ding, 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 right there, there's my answer. Okay? Great question. It was, what if you had something like negative 3 and then 24 and negative 24? That would not be correct. It has to be the exact number. Okay? They both have to be either negative 24 or positive 24. Okay, number 4. Take a minute and try and do this one. I'll help you. I'll start you off by drawing the tiles. I have x and negative 3 negatives equals 3x, and then 7 negatives. All right, continue from there. So on number 4, I draw a line at my equal sign. Remember, my x's have to go to the left. So positive x's, 3 of them. I'm going to draw 3 negatives. And what I do to one side, I have to do to the other. So over here, algebraically, I subtract 3x from each side. 1x minus 3x, negative 2x minus 3 equals 3x minus 3x is 0, negative 7. Well, that's because this cancels and these cancel. Now I will add 3 to each side. Negative 2x equals negative 4. I'm going to divide by negative 2. X equals 2. Now, the left-hand side goes into y1, right-hand side into y2, so I have x minus 3 and 3x minus 7. It's not negative 2 because a negative divided by negative is a positive. So I go into y equals. I put in there x minus 3 and 3x minus 7. I'm going to press second graph. I believe the answer is 2. So let's see. At 2, it's -1 and -1. So let me put in here 0, 1, 2, 3, 4. Hold this back up so I can fill it in right. Let's see. 0, -3, -2, -1. I hope that's what it was. Yes, and it's 0 again. It's -7. Yeah, that's it. Okay, and then my answer, right here, I see that that's my answer because y1 and y2 are the same. Number 5. Take a minute and draw that, and do this one. So on number 5, I have my equal to line. I have 5x. So I'm drawing 5 of my x's. Plus 8 equals, oh, these are a lot of tiles, 7x plus 8. Okay, remember, we want to move our x's to the left-hand side. So I want this 7x to go over to the other side. To move it, you have to do the opposite. So you have to, since it's positive, you have to subtract 7x from each side. Tile-wise, that means you would draw 7 negative x's. I'm just putting them on top of each other because those are going to cancel out. What is that? 4, 5, 6, 7. Okay, so 5 minus 7 is -2x plus 8 equals, the 7's cancel, and I have 8. Once you do that step, now you're back to a regular two-step equation. So then we subtract 8 from each side. -2x equals 0. Please make sure you put the equal sign. Some people do this. Some people go bring down the -2x. They cross out those 8's and they just write that. And they say, oops, that's the answer. Don't forget there's an equal sign and 8 minus 8 is 0. Because now you need to divide by -2. And your answer is 0. Now, to check it, left-hand side into y1. Whoopsie. So I have 5x plus 8 and 7x plus 8 into y2. So as I go to y equals 5x plus 8, and in y2, 7x plus 8. Second graph. I believe the answer is 0. y1 and y2 are both the same. That means that I am right. So I have -2, -1, 0, 1, 2. I knew that 0 is 8 and 8. Let's see. Again, the point of drawing the table is to make sure that you can find where your solution is by just looking at a table, by where y1 and y2 are the same. Okay, on the next ones, on number 6, your copies are it says like there's a line through it for whatever reason. But all you're missing is that one little tile right there. Okay, so, and on number 7, it's not, and the Y1, Y2, it's not a big deal. So for 6, 7, and 8, those of you in my class, go ahead and start working on those. I'll be back in just a second for number 6. So on number 6, when you went and drew the tiles, wrote your equation from the tiles, I have x plus 1 plus x plus 1. Oops, I don't mean to draw the line. Hold on, if you wrote 2x, don't mess it up yet. I was just writing what I saw, because the other way you could have written it was 2x plus 2 equals 3. That would have been the same thing. And that's okay. I probably would have, when I looked at it, I would have written it like this. So now, this is just a two-step equation, because the x's are already on the left-hand side. So you should have subtracted 2 from each side. 2x equals 1. Divide by 2. X equals, you can write 0.5, or x equals 1/2. Now, when you go to check this, 2x plus 2 goes into y1 and 3 into y2. The issue is going to be when we go to check it. I put in there 2x plus 2, and in y2, I'm going to put in there 3. Now, when I go second graph and I go to the table, there's no decimal. So what you'll do is go second window, type in what you think the answer is, 1/2, then second graph. Y1 and Y2 are the same right here. That means that you're right. So if you go second window, type in what you think the answer is, and go second graph, it will take you there. So I've got 0.5, 1.5, 2.5, 3, 3, there will not, on a linear equation, there will not be a spot where there are 2 answers. It is only going to be one spot. All right, so now, number 7. This one. Uh-oh. All right, to write this, what does this say? It says 4 groups of x plus 3. So I'm going to draw x plus 3. And I draw 4 groups of them. Equals 6x. Okay. With this has the distributive property. 4 times x, 4 times 3. 4 times x is 4x. That's what we have right here. 4 times 3 is 12. That's the 12 units. Equals 6x. Now, I want to show you on this kind right here, it's actually better to move your x's to the right. I know I kept saying left, okay? But I'll show you both ways. If I went up here and did the same way I've been showing you by moving my x's to the left, I would take 6x and subtract it from both sides. 4x minus 6x, negative 2x, plus 12 equals, and 6x minus 6x is 0. Now I need to move the 12 to the other side. So I'll subtract 12 from each side. Negative 2x equals negative 12. And then I would divide by negative 2. And I would get x equals 6. Now, the reason, again, that I am telling you to move your x's to the left is for the inequality unit. But when I do it, I actually look and see on equations, you can move this 4x over here by subtracting 4x from each side and getting 12 equals 2x. And then dividing by 2 and getting 6 equals x. You will get the same answer. The only reason I do this over here is for the inequality unit. Now, to check it, I've got 4 parentheses x plus 3, and in y2 is 6x. In y equals 4 parentheses x plus 3, and in y2, 6x. Second graph. I think the answer is 6. Oh, now wait, it still shows the decimals. Let me go back to second window, type in what I think the answer is, 6, second graph, and it'll make it correct again. Okay, so I'm going to write in my table 6, 7, 8, 9, 10. Oops. Again, once you fill in your table, circle where your solution is for where y1 and y2 are the same. Now on number 8, it says you do not need to draw tiles for this problem. This is a more advanced challenge problem. So let's go through and try and do this. I'm going to draw my line at the equal sign. Let's look at the left-hand side. There's a whole lot going on. Look in the very inside the parentheses, the very inside part. There's the distributive property right here. So what we're going to do is this first. I would draw my little arrows. I'm going to bring down the 2 and the 1 minus. Negative 3 times x, negative 3x. Negative 3 times 2, negative 6. Equals negative x. So all I did was the parentheses right here inside. Now let's look inside. Is there anything inside of this parentheses I can put away? Now, I have 2. I can put 1 minus 6. Negative 5 minus 3x equals negative x. Now I have the distributive property again. 2 times negative 5, negative 10. 2 times negative 3x, negative 6x equals negative x. Okay, so all we did was a distribute. Now, hopefully, we can do this from here. I'm going to go ahead and move my 6x to the right. I'm going to add 6x to each side. Negative 10 equals 5x. Divide by 5. Negative 2 equals x. Now on this one, be careful in the way you put it in the calculator. I have 2 parentheses, 1 minus 3 parentheses, x plus 2 parenthesis parenthesis. And then in y2 is negative x. So when you go to put it in there, so let's see, I've got 2 parentheses, 1 minus 3 parentheses, x plus 2, parenthesis, parenthesis. If you don't put 2 parentheses in there, it'll mess it up. Then in y2, I'm going to put negative x. Second graph takes me to my table. Again, you can either go second window or you can press the arrow key. And right here at negative 2, I know I'm right because y1 and y2 are both 2. So let's see. Filling in your table. 3, 2. And then circling where y1 and y2 are the same. All right, now you need to look carefully because, like I said, your papers are cut off on the word problem. Here's what it's supposed to say. Bethany Potato starts peeling potatoes at a rate of 3 potatoes per minute. Okay, so that's going to be important. 3 potatoes per minute. 4 minutes later, Jerry Spud joins her and peels at a rate of 5 potatoes per minute. Together they peel 36 potatoes. How long did each of them peel? Okay. What would X represent? So first off, Bethany is peeling 3 potatoes per minute. So this X right here is the number of minutes. So X represents number of minutes. Then it says X minus 4 because 4 minutes later Jerry showed up. So this is talking about, this is when the time Jerry showed up because he came in there 4 minutes later. So Jerry is 5 potatoes per minute. But see, X minus 4 is what we have to use for Jerry. Jerry didn't start when Bethany did. So this is Jerry. So now to write your equation, I'm going to have, I'll have to write it over here. Bethany plus Jerry equals 36 potatoes. They peeled 36 altogether. The 3 times X, what does it mean for the situation? This is how many potatoes Bethany peeled. How many potatoes Bethany peeled. Now the 5X minus 4, that's how many Jerry peeled. Now I need to figure out how many potatoes they peeled. To do that, we're going to go and solve our equation. Now, the 3X just comes down. And now you have to do the distributive property. So I have 5 times X, which is 5X. 5 times negative 4 is negative 20, equals 36. Add your X's together. 8X minus 20 equals 36. Add 20 to each side. 8X equals 56. Divide by 8. Now X equals 7. Okay? That's the number. So this right here is the number of minutes. Okay? So it says that Bethany, let's see, I'm doing blue. There you go. Bethany, remember she did 3 potatoes per minute. So she did three potatoes for 7 minutes, and she peeled 21. So she did for 7 minutes, she peeled 21 potatoes. Now, Jerry didn't peel for 7 minutes. How many minutes did he actually peel? 3, because you add x minus 4, 7 minus 4, that's 3 minutes. Jerry peeled for 3 minutes, and to figure out how many he peeled, it was 5 potatoes for each minute. So he peeled 15 potatoes. These two numbers together are supposed to add up to be 36 because that's the total that he peeled.